And today we're going to learn about zero acceleration. Well, what is zero acceleration? Zero acceleration is really simple. When a is equal to 0. Well, let's look at this graph, for example. As you can see, this is x, the y graph, t in the time graph, v in the y graph, t in the time graph, a in the y graph, t in the time graph. So, let's look at this. So it's in the uniform motion, if the graph's going to whoop, y equals mx plus v. So that means the slope of the velocity, since it's constant, is going to be a constant line. And since that is just a constant line, acceleration has to equal 0 because the slope of that is 0. Well, how do you prove that? Well, look at this. This is a common misconception. Most people don't know that acceleration will be 0 here. How do you figure it out? Well, you can take the average slope, the average rate of change. At the end of one graph, so y2 minus y1 over x2 minus x1. You do that for everything. You get the average slope. This is 0, so that means the average. The slope here would be 0. So if you have a uniform motion, that is 0 acceleration. There's also one other thing that's 0 acceleration. That's when you're in a stationary object. Well, this is like the most common one that people just won't say because, oh, they think everyone knows it. Well, this should be said because it's important, very important to say. Well, what happens if the object is not moving? Well, doesn't this look like this graph right here? Well, yes, it does. But basically, because it's the slope, it's not moving. The position is always going to stay the same. And time will always stay the same. Time always increases. So, what do you take the slope of this? Well, what's the slope of it? 0. What's the slope of 0? And these are the two good ways to show 0 acceleration.